In this video, I'm going to review the having clause in SQL, which of all the clauses is probably the least used. But when it is used, it's always used with kind of a group by clause. So just diving into the lecture, we'll talk about where it appears in the query first. So in the top right, we have our query that we've been reviewing to introduce all the SQL clauses. This time I didn't include the having clause in the prior examples because I think it's a little bit too much, especially when you're introducing the query at first. But you can see that the group by comes after the the having clause comes after the group by, and it's used with a group by clause. And what does the having clause actually do? It essentially provides a filter for your aggregated output. So this is after the aggregation is performed, and that's why it's ultimately used with a group by clause. And why is it necessary? Well, the where clause, if you recall, is performed on at the record level on the table source. So the where clause cannot restrict aggregated output after the fact based on aggregated values, such as in this particular example, count star, right? Because count star never exists in the original table source, so you couldn't ultimately use that as part of your where clause. And so what that means is that you're going to use the having clause to kind of filter out records after aggregation. Now, you can introduce non-aggregation functions in the having clause, but that's typically you would only do that with a group by. And ultimately, that's the least efficient way to do it because the where clause is performed on the table source at the record level. And so the degree to which you can filter the records before the aggregation is performed is ultimately the more efficient option. So I typically reserve any use of the having clause in my own work only to aggregation functions, just to limit the output after the fact. And so that is to say, I don't use it very often. But nonetheless, it's important. It's nice, particularly when you're trying to search for duplicate values. And so one of the things is you can count across values of a field that you want to find duplicates in. And then ultimately, if that count is greater than one, right, there's more than one record for a particular value, which may or may not, or should not have duplicate values. So that is one particularly useful case for the having clause. So to kind of reiterate the distinction between the where and the having clauses, the where clause filters records prior to aggregation, is performed on the table source or the original data that the query is being executed upon. The having clause filters out records records from the output after aggregation. So it's the where clause is performed on the table source. The having clause is ultimately performed on the output table. And the having clause uses the same logic as the where clause. And so there's nothing really new in terms of what you might put in a having clause. Again, to reiterate, you can't use aliases with the having clause. So that's the aliases. The only place you can use aliases, column aliases from your select list, is in your order by clause. So jumping in to the examples, and this is really taking what we did in the group by lecture and the conceptual examples and adding additional criteria to filter out or in rather records from the output of those grouping and aggregation functions. So again, the table here on the left is a fictitious table. We're selecting all fields, all records. So this is a table with 12 records. It has vehicle make, vehicle model, which is essentially your cars. It will have a make, which is the larger brand, and then they'll have that make will have multiple models typically. We also have fields for loan amount and loan term, and so those fields are meant to represent essentially customers financing the purchase of a car by borrowing money, which would be your loan amount, and then selecting a repayment period. So in this particular, the first record would be they borrowed $13,400 and they are repaying it over the course of 3 years. This is ultimately expressed in months for the purposes of this exercise. And so we reviewed this first query, right, in the group by lecture. And just to high level review that, and the output, we're selecting an aggregation function together with a field that is not part of an aggregation function. And so what we're essentially doing is telling SQL to count the number of records for each value of vehicle make. And because this field, vehicle make, is not part of an aggregation function, SQL will tell you that it either needs to be part of an aggregation function or it needs to appear in the group by clause. And so we put it in the group by clause. So ultimately, the count function is applied across values from the vehicle make field. And so to just look at the output, right, we have for each unique value of vehicle make, there will be a number of records associated with that value. So for the make of Ford, we have 1, 2, 3, 4, 5 records. And you can see that the output ultimately of the group by and the aggregation function reflects a count of 5 for the value of Ford. The rest of them are as expected as well. When you add 5, 4, and 3, you get 12, which ultimately represents the original number of records in the table. Now, jumping to the right, the query over here, we introduce a having clause, right? And so we do having count star greater than or equal to 5. And so what this means is we can look at our original output from the group, the aggregation function and the grouping criteria. And we can see that if we restrict the output, right, because the having clause is applied to the output, if we restrict the output to that must display a count greater than or equal to 5, there's only one record in the output that satisfies that criteria, the first record. And so ultimately, that is the only record that will be returned. This is kind of a way of showing you that the having clause is ultimately applied to the output of the aggregation, not at the record level, right? If we were trying to restrict the table over here using a field count star, it wouldn't ultimately make any sense to SQL because there isn't a field called count star, and then what are you actually trying to restrict if you're restricting a count to 5? It doesn't really make sense or isn't very interpretable with the original table. So again, having clause applied to the output of the group by. Moving on, the bottom right important note is that you cannot use aliases in the having clause. You would ultimately think, right, that there's a record count field here, and that's where the criteria is being applied, the having clause is being applied. But I did double check this, and you cannot use aliases in the having clause. So this means we could not have said having record underscore CT greater than or equal to 5. That's ultimately what SQL's doing. It's not what SQL's doing, but that's ultimately what's reflected in the output. However, again, you can't use aliases with the having clause. And then jumping over to the second example, which starts to get a little bit long, but this was example number 3 from the group by conceptual examples from that lecture video. And so in the first, essentially, we're performing aggregations across the same field as in the prior example, but we're performing ultimately 3 aggregation functions: a count function, summing the field values in the field loan amount, and then averaging values in the field loan term. And so if we just walk through the output here without a having clause, the third record, Toyota, there are 3 records, which we saw in the prior example, right? We've got Toyota 1, 2, 3. The sum of the loan amount for those 3 records, $13.4 thousand, $25,000, about $21.7 thousand, ultimately gets you to a $60,000 value for a loan term because we're summing values in those fields or in that field. And then ultimately your loan term, right, the average of that, 36 and 48 and 48 is 44. And we did discuss previously if this is an integer value, data precedence in SQL is going to supply an integer value for the output. which means that this field would not have any decimal precision, which might be important for whatever task you're kind of working with. Going to the second example, which introduces a having clause, and also in that having clause, a compound condition, so using the or logic, right? So we want, from this original output table, we want the record count, or the count of records, rather, to be greater than or equal to 5, or we want the average term field to be greater than 60. And so if we just go through the first criteria, having a count star greater than or equal to 5, we can see the first record satisfies that. So it will be displayed in the output, which we see in the first example. Even though it doesn't have an average term of greater than 60, using the or clause ultimately would include this record from the output, because it does satisfy the first condition. And then looking at the second condition, having an average loan term greater than 60, we can see that the second record satisfies that condition, and so it ultimately will be displayed in the output. And I'm going to jump over. The other thing is, note I use parentheses here, right, because operator precedence in SQL can give you unexpected results. SQL doesn't process the conditions in the order you supply, but rather it has a predetermined order based on the operators that appear in your logic. Trying to think of what else. We did not use aliases in the having clause, because ultimately that would have returned an error. We can't use aliases in our having clause, and so the fields that we're using ultimately represent the aggregation function on the field from the original table source. I'm going to jump to SQL Server Management Studio quickly. Just to review, ultimately that example that was displayed, let me pull it up here again. The example that was displayed, the kind of query we've been working with throughout this course, we're selecting a count of records across values of city, so grouping by the city field, values of city, and then from this table, we're all pretty familiar with that. We're restricting the original table source to only records where the value of state province ID is equal to 79. Again, grouping by values in the field city, but we're going to restrict the output only to those that have a record count greater than or equal to 10 for each value of city. And then we're going to order the output by values of city as well. So going over to SQL Server Management Studio, I'm going to set my current database first. So press F5 to execute, or you can use execute button. And so that was executed successfully. And so what I want to do is look at the output before introducing the having clause. So we're supplying a count of the records for each value of city. We're ordering by city as well. And again, the records are restricted to values from the table source that have state province ID equal to 79. So when I execute this, we're going to see various city names, which ultimately represent unique values for the field city where the state province ID is 79. And then we're going to see a count, the result of the count function over in the first column. And you can see here that SQL did not supply a name for the column, because we ultimately did not give SQL a field name for the output. So we can do that. And we'll just rerun it so that the output is a little more interpretable. You can see that the field name has now been updated. The reason it doesn't supply one, right, is that there isn't a field name from the table source associated with count star. And so we ultimately see counts of records for each value of city. So what's the having clause going to do, right? When we introduce the having clause, it's going to take this output and restrict it to records that only meet the condition that the count is greater than or equal to 10. So the first record will be kicked out. this record, this record, this record, this record. These will be maintained in the output. These records will be kicked out. This one will be maintained. It's equal to 10. So let's just verify that by running the query with the having clause. So if we run this query, I'm going to add the column alias here. We do that, we can see that ultimately those records that we identified were kicked out because they did not have a count greater than or equal to 10. A few other things I want to talk through here, right? Just to show you, if we were to put an alias here or reflect the alias name, we're going to get an error. There's an invalid column name. So again, that reiterates the fact that you can't use an alias in the having clause. Then I do want to show, right, if we didn't have a where clause here, we could introduce that logic. Actually, I don't know that we could because it's not displayed in the output window. But let's just walk through this again. Let me see. We might be able to actually, because if it doesn't take an alias in the clause, that probably means that there's some action performed on the table source, but we'll find out. So we could ultimately, and notice that there are 237 records here. Let me just make sure that that worked as intended. For 237 records here, there should ultimately be fewer records when we restrict using the where clause. Okay, 48. I just saw some of the city names come through. It makes sense since we're ordering by, but I wanted to verify that. So if we execute this query, you can see we have 237 rows. We'll see if this actually allows you to introduce additional restrictions on the output. It's not, because it's not contained in either the aggregate function or the group by clause, which means, and this is kind of what I thought would happen, we need to introduce it in our select list. And so that's, and then I'm pretty sure that this will actually work. So let's just do this quickly. I'm sorry, you have to actually group by the state province ID as well. So what is SQL doing now that we've introduced an additional field in the select list? Well, ultimately, SQL is going to perform that aggregation function across unique combinations of values for city and state province ID. And so that requires those two fields to appear in the group by. So I'm going to run this query just to show you that, right, this record would have been part of our original output. But this record here would not have been, because state province ID is equal to 58. And so we can introduce this additional clause to essentially generate the same exact output that we had before. So if we execute this, we'll see that there are 28 rows here. And with the having clause, should be 28 records here. And there are. And so the only difference here is that we've now included the state province ID field, which ultimately does not change the output because those values are all the same, value 79. Again, this is not the most efficient option for SQL, because with the where clause, this is performed at the record level. It's ultimately it's ultimately performed like first in the query plan. The where clause is, and so the processing is more efficient when you introduce this kind of logic that's not applicable to the aggregation function or the results from the aggregation function. It's better to introduce that logic in the where clause. So that basically takes us through all those examples with the having clause. Pretty straightforward, but some important pieces to recognize there.